Okay, we have finished the first chapter, risk and return. So today, first, let's look at these chapter review questions. The first question says, what are the two most common measures of risk and how are they related to each other? Well, this one is simple, right? So basically, we have learned to measure risk. The very basic kind of measurement is variance. So variance. And a very much closely related measure is standard deviation. And of course, they are very much related because standard deviation basically equals the square root of variance. The second question is, do expected returns of well-diversified large portfolios of stocks appear to increase with volatility? A related question is the third one. Do expected returns for individual stocks appear to increase with volatility? Well, if you recall what we have learned during the last class, you should know that for large portfolios, right, the expected return indeed increases with volatility. And for individual stocks, we don't observe such relationship. And it's also important for you guys to understand why do we have this kind of observation. So the starting point is we know that investors, they should be compensated for bearing systematic risk. So this means there should be a positive relationship between expected return and systematic risk. And for large portfolios, because large portfolios are well diversified, so basically volatility of a large portfolio measures systematic risk. That's why there is this positive relationship between expected return and volatility for large portfolios. However, for an individual stock, volatility measures both systematic risk and firm-specific risk. So there shouldn't be a positive relationship between expected return and volatility for an individual stock. Okay, the fourth question, what is the difference between common risk and independent risk? Well, if you wanted to be precise, you could use probability theory to precisely define common risk and independent risk. So here, without resorting to probability theory, let's just say common risks are risks that are perfectly correlated, and independent risks are independent. And obviously, if risks are independent, then they're uncorrelated. So correlation here plays an important role in determining whether risks are common or independent. The fifth question, explain why the risk premium of diversifiable risk is 0, and why is the risk premium of a security determined only by its systematic risk? Well, basically, if a risk is diversifiable, then investors can eliminate this kind of diversifiable risk by building a large portfolio. So in the end, the portfolio will only contain systematic risk. So basically, through diversification, as an investor, you can eliminate firm-specific or diversifiable risk. So you will not ask for compensation. So there is no risk premium for bearing diversifiable risk. However, if a risk is systematic, then even through diversification, you cannot eliminate systematic risk. So as an investor, you would ask for compensation if you're bearing systematic risk. That is, there is risk premium for systematic risk. Okay, that's for the first chapter. So let's proceed. So let's proceed to the second chapter. So let's talk about the theory of CAPM, right? So basically, this chapter is about efficient portfolio, and based on efficient portfolio, we will actually derive CAPM. CAPM is short for Capital Asset Pricing Model. This is a very important model. It's a very basic model, help us to calculate the cost of capital. And you can see that this chapter is basically based on chapter 11. Right? Okay, now we would first talk about efficient portfolio. So what is the efficient portfolio? What is the inefficient portfolio? Right? We would call a portfolio as a inefficient portfolio if it's possible we could find a better portfolio. Right? That's just a very simple definition. And to be more precise, a portfolio is inefficient if we could find another portfolio which is better in both expected return and volatility. So what is an efficient portfolio? Well, a portfolio is efficient if you cannot find a better portfolio, right? Or you could follow this definition on this page. It says that a portfolio is efficient if there is no way to reduce the volatility of the portfolio without lowering its expected return. An equivalent definition is, and if an efficient portfolio can be defined as a portfolio such that there is no way to increase the expected return of this portfolio without increasing the volatility of the portfolio. Okay, now let's look at the example. So basically, we will start with a very simple case of two stocks, and we will use the two stocks to build a efficient portfolio, and then we will consider more complicated cases. And I also want to point out that the definition here is not very good. So if you proceed and see how these examples work, I'm pretty sure you will get a clear idea what is an efficient portfolio, what is an inefficient portfolio. Okay, now let's see what kind of example do we have here. So we're looking at two stocks. Right? So we're looking at Intel and Coca-Cola. And we have the following data. So Intel has an expected return of 26% and a volatility of 50%. And Coca-Cola has an expected return of 6% and a volatility of 25%. So now, as an investor, your task is to build a portfolio with these two stocks. Of course, when you're building a portfolio, there are a lot of ways to build this portfolio. Just think about this. Let's say you have $1,000. Now you want to ask yourself, how much money should I put into Intel versus how much money should I put into the Coca-Cola stock, right? Should I put 400 into Intel stock or 800 into Intel stock? This is obviously an important question. And you can see that this question is essentially about what is the optimal portfolio weights of Intel and Coca-Cola when you are building your portfolio, right? So let's solve this problem through experiment. So what we're gonna do is we change the portfolio weight of Coca-Cola. So you can see that the second column gives you the portfolio weights for the Coca-Cola stock. And you can see that you're increasing Coca-Cola stock's portfolio weight from 0% to 100%, right? And we have 6 numbers, right? For example, this one is 20%, 40%, 60%, and 80%. And by changing portfolio weights, we could basically calculate the expected return for this portfolio and the volatility for this portfolio. So let me show you how to get, let's say, okay, let me first remove these marks. So let's say now we want to focus on this row, right? This is our focus here. Let's see how could we get expected return and volatility. So we have 40%. So we have 40% of Coca-Cola, right? So we have 40% of Coca-Cola. We have 40% of Coca-Cola, 60% of Intel. And to calculate the expected return of the portfolio, then you can see that expected return of the portfolio equals 26% times 60% plus 40% times 6%. So I guess this gives us 18%. Okay, let me see if it's actually 18%. So 26 times 60% and 40% times 6%. And yes, this gives us 18%. Now, standard deviation. Standard deviation is basically the square root of variance. And variance equals weight squared, right? So weight squared times Intel stock's standard deviation squared plus weight of Coca-Cola's squared times Coca-Cola's volatility squared. And we know that these two stocks are uncorrelated, so we don't need covariance here. And this gives us 31.6%, right? So what I'm trying to show you here is, given the weights, you could calculate expected return and the volatility for different weights. Okay, so after solving the return and volatility, so let's focus on these two columns. Right? Next, what we're gonna do is we will draw these expected returns and volatilities, and then we will find out we could connect these dots, and then we could get a certain type of curve. Right? So what we're gonna do here is, so basically, let's say the horizontal axis is given by volatility. Let's say the vertical axis is expected return. So let's say it's 10, 20, 30, 40, 50. And similarly, 10, 20, 30, 40, 50. So let's just put these two columns onto this two-dimensional graph. So let's say if standard deviation is 40, then expected return is about 26. And if it's 40, then expected return is about 22. So it's here. And if it's 31, we get a return of 18, right? And continue to do this, 25, we get a smaller return. And then 22, we get, oops. So if return, if volatility is 25, we get almost 14 here. So we get 14 here. And if volatility is 22, we have 10 here. And 25, we have 6. Okay, it's a, okay, I'm not a good, so I am not good at drawing this curve, but basically the curve should look something like this, right? Okay, I will give up. So I will just show you this nice picture from the textbook. So basically, following the same steps. That is, you draw out points according to the volatility, right? And the expected return. You could find out these dots, right? And next, you would connect these dots. This gives you this red curve and this blue curve. Okay, now let's look at this curve, and we could learn about efficient portfolios versus inefficient portfolios. So let's just pick a portfolio, right? Let's just pick this guy. So this portfolio is about investing $0 into Intel and put all your money into Coca-Cola stock, right? Now, we compare this portfolio with a different one. Now let's look at this guy here. So for this portfolio, right? Okay, let me change to a different color. So let me use maybe this purple color. Okay. Now, if you compare these two portfolios, you could see a very interesting pattern. That is, these two portfolios have the same volatility. However, the portfolio on the top has a much larger return, about 13%, versus the portfolio on the bottom, about 5%. Now, this basically tells you that the portfolio on the top is better than the portfolio on the bottom, right? Because again, they have the same volatility, but the top portfolio has higher return. So in this case, we could say that this bottom portfolio is inefficient, right? Now, let's look at this curve here. So if you look at this blue curve, right, you can see that every portfolio on this blue curve is inefficient, because you could basically pick any point on this blue curve and you could just move upward. Then you could find a portfolio which is strictly better than this portfolio on the blue curve. This tells you that all portfolios on the blue curve, they're inefficient, right? And you can also see that portfolios on the red curve, they are efficient because there's no way you could find a portfolio which has the same volatility as the portfolio on the red curve. However, with a higher return, right? You cannot find such a portfolio. So to summarize, all portfolios on the red curve are efficient portfolios, and all portfolios on the blue curve, they're inefficient portfolios. Okay, I hope this gives you a clear idea about the definition of efficient portfolio and inefficient portfolio. Okay. Oh, I forgot to mention this important point. So let's go back to this picture here. So basically you can see that as an investor, right? As an investor, you should never invest in inefficient portfolios. That is, you will not invest in these portfolios. However, now the question becomes, which portfolio should you choose on this red curve, right? Should you choose this one or should you choose this one? Well, the answer is, it depends. It depends on your risk preference. If you are very conservative in taking risk, then maybe you should choose this. Because obviously, this portfolio has a smaller risk, right? Of course, it also has a smaller return. And if you're very, very aggressive in taking risk, in this case, maybe you should invest in this portfolio, right? It has the largest possible risk, at least in this picture, right? So basically, this tells you that depending on your risk preference, you could choose any portfolio on this red curve. Okay. Now let's see this example here. It says, Emily Ashley has invested 100% of her money into Coca-Cola stock and is seeking investment advice. She would like to earn the highest possible expected return without increasing her volatility. Which portfolio would you recommend? So basically you can see that now she is investing in an inefficient portfolio, right? So basically she should make some changes. And the problem says she would like to earn the highest expected return possible without increasing her volatility. So basically we should keep the same volatility in this new, more efficient portfolio. So obviously, we should invest in this portfolio, right? So the recommendation here is we should invest 40% in Intel and 60% in Coca-Cola, right? Okay. Now let's expand what we have learned about this efficient portfolio and see by adding more complexities what kind of additional results we can get. So basically in the previous example, when we talked about Coca-Cola and Intel, we assumed these two stocks are uncorrelated, right? This is not a realistic assumption. Generally, in the stock market, there are correlations between different stocks. So here, let's say we examine the more realistics of stock returns are actually correlated, right? So here, we are looking at different level of correlation. To be more precise, 5 different levels of correlation. So here we have -1 correlation, and this one is okay. I'll write it here. So we have -1 correlation. So this curve has -0.5, and this one is about 0 correlation, and this one is 0.5. Oops, sorry. I was marking the wrong correlation numbers. So this one is correlation equals 1, and this one is correlation equals 0.5, and this one is correlation equals 0. And this one is correlation equals -0.5, and this one is correlation equals -1. Now, what kind of result you can get from these 5 different curves? Well, you can see that if you reduce correlation, you will get better curves, right? So what does better curve mean here? Well, if you compare, right, let me pick a color. If you compare this curve, right, the curve with -0.5 correlation, with this curve, right, the curve with -1 correlation. If you compare these two curves, what you can see here is the curve with a correlation of -1 is better than the curve with the correlation of -0.5. The reason is because if you compare these two portfolios, right, this portfolio and this portfolio, you can see that the portfolio on this on this curve with -0.5 correlation has a lower return, right, compared with the portfolio on this -1 curve, right? Even they have the same kind of volatility. So this basically tells you that portfolios on the curve with lower correlation, they are more efficient compared with the portfolios on the curve with a higher correlation, right? This is a very natural result. This result is somewhat expected. Why? Well, remember we learned in last class how to calculate a portfolio's a portfolio's variance. So let me remind you the formula. The variance of a portfolio of 2 stocks equals the first stock's portfolio weight squared times the variance of the first stock and the second stock plus 2 times x1, x2 times correlation between 2 stocks and the standard deviation of stock 1 and the standard deviation of stock 2. Now, the focus here is this guy here, right? Correlation here. So one thing here you can see that if you maintain portfolio weight, maintain the expected return of stock 1 and stock 2, what you can see here is if correlation becomes smaller, then the variance of the portfolio will be smaller, right? So this is exactly what we have observed in this picture. That is a portfolio and the curve with smaller variance, with smaller correlation will have smaller variance, right? Just compare this portfolio and this portfolio, right? Obviously, the portfolio on the left has smaller variance, right? Okay, great. Okay, now let's talk about the third realistic point, right? So in the previous 2 examples, we assume you would only buy stocks, right? You would only buy Intel stock, or you would only buy Coca-Cola stock. However, in reality, you could also do a short sell, right? So basically, when you're buying a stock, you're taking a long position, right? However, you could also take a short position. So, what is a short position? Well, when you're doing a short sell, then you're taking a short position. To be more specific, you will first borrow a stock, and then you will sell this borrowed stock. And later in the time, right, you will buy back this stock and return it. Now, why do you want to do a short sell? Well, because you expect the stock price to decline in the future, right? For example, if today's Apple stock price is $400, and I expect in 1 month, Apple's stock price will decline to $300. How do I take advantage of this stock decline, right? How could I earn money? Well, what I can do is today I will sell a borrowed share, right? I will sell it for $400. And in 1 month, if my prediction is true, I could buy back this Apple stock at $300. So you can see that I could earn this $100 difference. To be more precise, this $100 decline in Apple stock price, right? That's my profit. Now, let's examine how the curve will change if we allow for short sell, right? Obviously, before examining the picture, we will have to go through this example here. So basically, if you're short selling a stock, you will have to think about your portfolio weight. Essentially, you can see that if you're taking a long position, portfolio weight is positive. So clearly, if you're taking a short position, then portfolio weight is negative, right? Okay, cool. Let's solve this example. Suppose you have $20,000 to invest. You decide to short sell $10,000 of Coca-Cola and invest the proceeds from your short sale plus your $20,000 in Intel. What is the expected return and the volatility of your portfolio? So to solve this, we need to first find out the portfolio weights of Coca-Cola and and Intel. So the portfolio weight of Coca-Cola is given by the value of Coca-Cola stock divided by the total value of your portfolio. So here you can see that Coca-Cola stock has a value of, importantly, negative $10,000. So it's minus $10,000. And what is Intel stock's value? Well, it's $30,000. Because the problem says you will short sell this amount and you will use this amount plus your original $20,000. So now you will have a $30,000 of investment in Intel stock. Now, what is your total portfolio value? Well, if you have minus 10,000 in Coca-Cola, and then if you have positive $30,000 in Intel, then the sum of these two numbers gives you the total value of your portfolio. So the total value of your portfolio is $20,000, right? $20,000. So the portfolio weight of Coca-Cola stock is minus 0.5. And for Intel, the portfolio weight is 1.5. Okay, great. Now we could talk about expected return, right? So expected return is the portfolio weight of Coca-Cola times 6% plus 1.5 times 26% of Intel's return. This gives us 36%. Right. Okay, now volatility, right? So volatility of the portfolio equals square root of the variance, which is minus 0.5 squared times 6% squared. Oops, no, it's not. Times Coca-Cola's volatility squared, which is 0.25 squared, plus Intel's portfolio weight squared, which is 1.5 squared, times Intel's volatility squared, which is 0.5 squared. Let's see what's the answer here. So this gives us 36%. Note that I'm not adding covariance here because we assume the correlation between Intel and Coca-Cola is just 0. Okay, now we could finally examine what your curve, right? What your portfolio frontier would look like if you could do this short sale. So what you can see here is the curve will basically expand, right? So these are the expanded sections, right? Basically, you can see that for this point, it basically says that you will do some short sale in Intel, right? 20% short sale in Intel. So the portfolio weight on the no. For this point, you're doing this 20% short sale on Coca-Cola, and the portfolio weight of Intel would become 120%, right? And a very basic result is, again, the portfolio weight on Intel and the portfolio weight on Coca-Cola, if you add up these two numbers, they should be equal to 1, right? So this is a useful check when you're solving problems. You want to make sure that when there are a short sale, still the sum of all portfolio weights should be 1. Okay, now let's consider the efficient portfolios with many stocks. So to be more precise, we will add a third firm, which is this Bohr Industries. Right? Now let's see how the efficient frontier, the efficient portfolios will change. So previously, the portfolio weight with 2 stocks is given by this black curve. Of course, now I'm marking it in a different color. And you can see that the efficient frontier with 3 stocks is better, right? Again, what does better mean here? Well, we could do the same exercise. You can see that if I pick 2 portfolios, right? You can see that these 2 portfolios on the red curve and on the black curve, they have the same return, but the volatility but the volatility of the portfolio on the red curve is actually lower. So this red curve is a better curve. Or you could fix volatility, right? You could do something like this. You could say, okay, I am comparing a portfolio of this and a portfolio of this. Then you can see that both portfolios have the same volatilities, but the portfolio on the red curve has a higher return. So in this case, you can see that, again, red curve is a better curve, right? Okay, so basically what you can see here is, when you're having more stocks to construct your portfolio, you will have a better efficient frontier. And interestingly, you can see that investing in a single stock, right? These three dots represent you're investing in a single stock. And we can learn that it's never efficient. It's never wise to just invest in a single stock, because none of these single stocks is on this efficient frontier, is on this red curve, right? So basically this tells you that it's important to diversify your portfolio, right? So this is basically a very simple justification for diversification. Okay, now we could continue to add more stocks, right? In this case, you can see that we're having 10 stocks, right? And we could compare the portfolio, the efficient portfolio curve with the three stock case, right? And you can see that we're having the even better efficient frontier, right? Basically, if you compare these two portfolio, right, you can see that the portfolio on this green curve has the same return on the portfolio on the red curve, but its volatility is lower. So green curve is a better efficient frontier. Oh, maybe I forgot to mention that these curves, right? These curves, they are called efficient frontier. Right? These are efficient frontiers. So basically, these are frontiers of efficient portfolios. Okay, now let's talk about the second topic. So the second topic is about the efficient frontier with risky assets and a risk-free asset. If you think about the first section, when we constructed the efficient frontier, we only talked about stocks, right? Our major focus are two stocks, Intel stock and Coca-Cola stock. But in your real life, right? In real life, generally you can invest in risky assets such as stocks, and you could also invest in a risk-free asset such as a very low-risk bond, right? Such as T-bills, or you could put money into your savings account. So let's say the annual rate is 2%, then this annual rate is almost risk-free, right? This will have some implication on this efficient frontier. You can imagine that basically if you don't like risk, or if you're a very conservative investor, what you're gonna do is possibly you will invest a large portion of your money into the risk-free asset. On the other hand, if you're young and you're very aggressive in taking risk, then possibly you will want to borrow money, right? You will want to borrow money to invest in stocks, right? So basically you can see that the ability to allocate your money between risk-free asset and a risky asset will actually give you many different kinds of portfolios depending on your risk preference. Okay, now let's first learn some mathematics to calculate the portfolio's return and the portfolio's standard deviation when you have the opportunity to invest in this risk-free asset. Okay. So now let's consider the case that you have basically two portfolios. This is the first guy, portfolio P. This is a risky portfolio. You could consider this portfolio as a portfolio of stocks. So it's an all stock portfolio. So let me write this down. You could consider this as a all stock portfolio. And RF, this is a risk-free asset. So now you could invest your money into both this all-stock portfolio and this risk-free asset. And now the question is, what is this expected return of this combined portfolio, right? What is this expected return of RXP? Again, portfolio XP is a combination of risk-free asset and this all-stock portfolio. Well, this is actually pretty simple, right? We have basically learned about this. We know that if the portfolio weight, right? If the portfolio weight on this all-stock portfolio is given by X. If the portfolio weight on the risk-free asset is given by 1 minus X, then clearly the expected return of this combined portfolio XP equals 1 minus X times the risk-free rate plus X times the expected return of this all-stock portfolio, right? So basically, we could further simplify this formula and we will have this result. That is risk-free rate plus the fraction of the money into the all-stock portfolio times the expected return of the all-stock portfolio minus risk-free rate. Now, what about the standard deviation? Well, let's see how could we find out the standard deviation. So the standard deviation is basically the square root of the variance of the combined portfolio. And the combined portfolio has two components: risk-free asset with a portfolio weight of 1 minus X and the all-stock portfolio with a portfolio weight of X. So here, according to the formula we have learned about, then the variance of this combined portfolio is the portfolio weight of risk-free asset squared times standard deviation of this risk-free asset squared plus X squared standard deviation of the all-stock portfolio squared plus 2 times portfolio weight times covariance. Okay, I am running out of space here. So times covariance between the risk-free asset and the all-stock portfolio. Now, what you can see here is this guy is 0, right? Because risk-free, because risk-free return is just a number. It's not a random number. So the standard deviation of a number is always 0. So this one has to be 0, right? Which means this whole thing will become 0. And this one is also 0. Why? Well, because covariance between a risk-free rate and a all-stock portfolio return has to be 0. Right? Because again, risk-free rate is a number. The covariance between a number and a random variable is always 0. So in this case, we could basically cross out these two terms, these two values. So this leaves us with X SD RP, right? So basically the standard deviation of this combined portfolio equals the fraction of the money you put into this all-stock portfolio times the standard deviation of this all-stock risky portfolio. Okay. So whenever you're borrowing money to invest in stocks, this is called buying stock on margin, or you're using leverage to make your investment. Margin investment is generally very risky. If you're right, then you could earn a lot of money. But if you're wrong, you could lose a lot of money. So now let's look at the picture here and see what is the implication of being able to invest in a risk-free investment. So first, here we have our original curve, right? This is the efficient frontier of risky investment, right? You could consider this efficient frontier as the efficient portfolios of all stocks. And now next, we have the risk-free investment of 5%, which is here, right? So now let's say, as an investor, you're thinking about investing in risk-free investment and this all-stock portfolio P here, right? Now, let's see what kind of total portfolio you will get if you put different fraction of your money into the risk-free investment. So first, let's say you're putting 50% of your money into this risk-free investment. This implies that you will be here, right? So you will be in the middle between the risk-free investment and the portfolio P. Now, let's say you really want to take some risk. So what you're gonna do here is you're buying stock P on margin, right? So we are looking at, let's look at this case, right? So in this case, it basically means that you're putting this portfolio weight 150% into this risky portfolio P. It basically means that if you have $100, right, then you will borrow $50 to buy $150 of risky portfolio P, and you will owe $50 of debt. And if you look at this portfolio, right, you're even more aggressive. The portfolio weight on the risky portfolio P is 200%. So this basically means if you have $100, then you will borrow $100. You will have a total $200 to buy stock P, and you will owe $100, right? Okay, now let's look at the next question, next example. So let's say you have $10,000 in cash, and you want to borrow $10,000 at a 5% interest rate to invest $20,000 in a portfolio Q with a 10% expected return and 20% volatility. So the question is, what is your expected return and the volatility of your investment? And what is your realized return if Q goes up 30%? What if Q falls by 10%? So let's first start with the first question. What is the expected return and volatility of your investment? To solve this, we're gonna use the formula we have just learned about, right? We will use this formula and this formula. So the expected return of portfolio XQ is given by the portfolio weight. So first we have to find out what is this portfolio weight of your investment in portfolio Q, right? So, okay, let's first start with X. X, right? What is X? So X is given by your investment in portfolio Q, which is $20,000, divided by the total value of your investment. So you have $20,000 in portfolio Q, and you have also borrowed $10,000. So the portfolio weight is 2 here. And now the expected return of this combined portfolio of risk-free investment and portfolio Q is given by X times portfolio Q's expected return, which is 10%, plus 1 minus X times interest rate, which is 5%. So we get 20% minus 5%, which is 15%. Let me see whether I'm right. Okay, it's 15%. So what I can see here is if you just invest in portfolio Q, your expected return is only 10%. But if you're buying on margin, that is, if you're borrowing money to buy this portfolio Q, the expected return actually becomes larger. So this basically tells you why some people will buy on margin. It's really because if you expected a positive return, then using margin will magnify your return, right? In this case, return increases from 10% to 15%. Okay, great. Now let's look at the second question. If Q goes up 30%, well, if Q goes up 30%, we can actually calculate your realized return. So your sorry. Okay, so if Q increases by 30%, then the combined return is X times 30% plus 1 minus X 5%, which is X equals 2, so we get 60% minus 5%, which is 55%. And now the third one says, what if Q falls by 10%? Well, the calculation is very similar here, right? So if Q decreases by 10%, then RXQ equals 2 times minus 10% minus 1 times 5%. So this gives us minus 25%. Yeah. Okay, let me check if I okay. Now, a very interesting observation from this problem, you can see that if you're not using leverage, right? If you only invest in portfolio Q without borrowing money. In this case, you can see that the difference between your return is 30% versus minus 10%, right? But now if you're using leverage, the difference becomes larger. It's 55% versus minus 25%, right? This difference is about is 90%. No, it's 80%, right? So it's pretty large, right? So you can see that basically leverage increases your risk. So you can see that there is no free lunch in the market. If you compare, if you also look at this result, you can see that basically using leverage, you can have higher return. However, at the same time, the risk of your portfolio also becomes higher. Okay, now let's talk about tangent portfolio. So what's the rationale? What's the motivation, right, to talk about tangent portfolio? Well, the reason is because if you look at this picture here, right, you can see that this portfolio P is not the best portfolio you want to invest in, right? Why? Why this is the case? Well, let's say I'm looking at this portfolio here, right? And now if I connect the risk-free investment and this portfolio, okay, let me use a thicker line. Okay, let me use a thicker line here. Okay, now let's look at this portfolio. And if you connect the risk-free investment and this different portfolio, now you can see that this curve is a better curve compared with this blue curve, right? Because every portfolio on this new curve has a larger return while keeping the volatility the same, right? And you can see that you can continue to do this movement. What you basically want to do is you want to pivot. You want to pivot this straight line in this counterclockwise direction, right? So you can see that if you have a line like this, you will be even better, right? So in this case, you're investing in the risk-free investment and a portfolio like this. You might want to say, okay, if I draw a line like this, it's even better, right? But this is not realistic. This is not realistic because you cannot find a risky portfolio on this line. Basically, your line has to at least touch this red curve, right? You have to at least touch this red curve, right? So basically, this tells us this portfolio is the best portfolio we can have here, right? So so this guy has a name, right? It's called tangent portfolio. Why this is called tangent portfolio? Well, it's because this line here, right? This line is tangent to this red curve. Tangent basically means if two curves, they just barely touches with each other, then we could say these two curves are tangent with each other. If you have learned about calculus, then you would know the precise mathematical definition, but of course I will skip that. Okay, great. So this is basically about tangent portfolio. And after learning about this tangent portfolio, we could introduce Sharpe ratio. So now let's look at this guy here and let's introduce Sharpe ratio. So if you look at the slope of this curve, right? What is, or how do you define slope? Well, in your high school, you have learned it's rise over run, right? So this is rise. And this is run. So what is rise here? So the rise equal to the expected return of the tangent portfolio. So do we have a name for tangent portfolio? Okay, I'll just use ER. So the expected return of the tangent portfolio minus 5%, which is the risk-free rate, right? And what is run here? The run basically equals the standard deviation of this tangent portfolio, right? So let's call this as sigma p, which is just, sigma basically represents standard deviation. So in this case, we know that slope of this line equals expected return minus risk-free rate divided by standard deviation, right? In finance, we call this slope as Sharpe ratio because William Sharpe in a paper proposed this. So this is basically the definition of Sharpe ratio. That is, Sharpe ratio is defined as portfolio's excess return divided by portfolio's volatility. So this is a very widely used measure to measure your investment performance. Generally, you want this Sharpe ratio to be as large as possible. You could see that. You could see this here. You can see that because Sharpe ratio is equivalent to the line's slope. So basically, you can see that this line has smaller Sharpe ratio, right? Right? Compared with this line, right? This guy, right? This line has larger Sharpe ratio. And obviously, the line on the top is preferred, right? This is the preferred line. So basically, this tells you why Sharpe ratio, So this basically tells you why a larger Sharpe ratio is preferred to lower Sharpe ratio. You could also see that Sharpe ratio basically is a ratio of reward to volatility, right? Because, oops.
Okay, I found this on the web for ratio of reward to volatility.
Sorry, guys. So basically, this is reward. Of course, this is volatility, right? So this tells you that if Sharpe ratio is higher, then it means that you're getting higher reward from bearing volatility, right? So higher reward, of course, is a good thing, right? So that's why higher Sharpe ratio is preferred. Also, you can see that basically, what is a tangent portfolio? Well, tangent portfolio is basically the portfolio which gives you the largest possible Sharpe ratio, right? Right? Maybe it's worth writing down. So this is the portfolio which gives you the largest Sharpe ratio. Okay. Okay, great. Now let's see. Let's see what kind of investment result we can get from this efficient portfolio. So basically, what you can see here is we could actually get several results. The first result is with risk-free investment, this red curve is not efficient anymore, right? The actual efficient frontier is given by this sort of yellow-green line, right? This line is the efficient frontier, right? That's the first result we can get. Now, what's the second result? The second result is investors, they will always stay on this line, right? They will always stay on this line because this is the efficient frontier. However, we cannot pin down the exact portfolio or the exact position on this line. That is, if this investor is very aggressive in taking risk, maybe this investor will pick a portfolio on this right hand side, right? Very high volatility and very high return. And if this investor does not like risk, now this investor could be very conservative, right? Putting most of his money into this risk-free putting most of his money into this risk-free investment. So basically you can see that depending on risk preference, a investor could stay at any point on this line, right? Now the third point, which is subtle, is every investor will only invest in two kinds of assets. A investor will only invest in the risk-free investment and the tangent portfolio, right? How could you see this? Well, you can see that if an investor is here, then it basically means this investor is borrowing money by this efficient frontier. It means this investor is borrowing money and buy this efficient portfolio. Now, if the investor is here, then it means the investor will put 50% of his money into this risk-free investment and 50% of his money into this efficient portfolio. So again, this investor is only investing in risk-free investment and efficient portfolio. And now, if the investor is here, then this investor is basically only investing in risk-free investment, right? So you can see that this is really a very simple world. Every investor will buy only a risk-free investment and this tangent portfolio. The difference is, depending on their risk preference, they will put more or less money into this tangent portfolio. Okay, let's see whether I could finish. Okay, let me finish this example here. So it says your uncle is asking for investment advice. So now he has $100,000 invested in portfolio P. Right? Let me make this larger. Invest in P, right? This has an expected return of 10.5 and a volatility of 8. Suppose the risk-free rate is 5% and the tangent portfolio has an expected return of 18.5% and a volatility of 13%. To maximize his expected return without increasing his volatility, which portfolio would you recommend? If your uncle preferred to keep his expected return the same, but reducing his volatility, which portfolio would you recommend? Okay, now let's look at the first question, right? So the first question says, maximize his return without increasing his volatility. On this graph, it basically means originally he was here. Now you want to move upward to this portfolio, right? Mathematically, how do you solve this? Well, let's assume he would put a fraction of x into the tangent portfolio, right? Into the tangent portfolio. Portfolio. And the problem says he would want to keep his volatility the same. Well, what is his volatility? So originally the volatility was 8%. So he would want to keep 8% the same. And now let's see what is the tangent portfolio's volatility. Well, it's 18.5, right? And we have learned we will combine risk-free asset and a risky portfolio. Then the combined portfolio's volatility equals x times the risky portfolio's volatility. So this tells us x equals 8 divided by 18.5, which is, let me see. Oops, that's weird. I think I made some, oh, sorry. The tangent portfolio actually has a volatility of 13%. Sorry for that. So 8 divided by 13, this gives us 0.615, right? So basically the uncle should put 61.5% of his money into this tangent portfolio. Okay. Okay, great. Now let's look at the second question. So the second question says, if your uncle prefers to keep his expected return the same, but minimize his risk, which portfolio would you recommend? So again, we assume he puts x fraction of his money into this tangent portfolio. So we know that if he wants the expected return the same, then the expected return should be 10.5, right? Equals the risk-free rate times x times the expected return of the tangent portfolio minus risk-free rate, which is 5% plus x. So the tangent portfolio has expected return of 18.5%. 18.5% minus 5%. Right. So this basically solves. So what's the answer here? So this solves 0.407, right? So in the second case, the uncle should put about 40% of his money into this tangent portfolio and invest the other 60% into this risk-free asset. Okay, that's for today's class.